Hi everyone, and welcome to our video on solving a trig equation with a special angle. Now, these trig equations are just a single trig function with something weird going on with the angle. So here we've got an addition along with a 2 theta. All right, well, the main idea still, so like above, I kept all that work, is to isolate the trig function of whatever. So that means instantly on this problem, we would just divide by 2. So often they make you do 1 or 2 little steps to get the trig function all by itself. So we would have sine of 2 theta plus pi fifths equal to the square root of 2 over 2. And then we could use our unit circle. So our trig function is isolated now. And where sine is the square root of 2 over 2 is in the first quadrant and the second quadrant, right in the middle of them. Okay, so that's pi quarters and 3 pi quarters. So that means this big angle, whatever's in here, so we would have 2 theta plus pi fifths should equal the pi quarters, and again we'll just instantly say plus 2 pi k to it, comma 3 pi quarters plus 2 pi k. And so our goal is to get all solutions first. So that means I want theta all by itself. And often we said we should get a common denominator with our answers, so might as well do that same pattern. So let's multiply these by 4 so that we've got 2 theta plus pi fifths equals pi plus 8 pi k all over 4, comma, and then 3 pi plus 8 pi k all over 4. All right, and then now we have a minus pi fifths that we can do. So again, we want theta all by itself. So that means we should subtract can't talk right now. Subtract pi fifths on each side, which is really doing it to the left side and then to the 2 answers. Well, again, we would say we need a common denominator. So this is bad because we need to do extra work. That means this now also needs to get multiplied by 5 on the top and bottom. And these need to get multiplied by 4 on the top and bottom. That will now give us 2 theta by itself at least. Okay, so we're going to do a couple steps in one here. So this 5 distributes. Let's get a big fraction going. So we'd have 5 pi plus 40 pi k minus 4 pi. So that pi and that 4 were minused. And then the common denominator is 20. And then comma, again, that blue 5 distributes. So 15 pi plus 40 pi k, and then 4 times pi is getting minus 4 pi. 5 times 4 is the denominator, 20. Okay, we're almost there. We do notice, or we will notice, that we do have some like terms in there. So we should combine those. And I'm running low on space here. Let's put it up with this one, and let me even erase a little bit of that last one. Okay, so sorry, let's get rid of those. Okay, let's now write it. Okay, so I'm going to block that off. Okay, so combining those highlighted terms, we have 2 theta is equal to pi plus 40 pi k over 20, comma, 11 pi plus 40 pi k over 20. And then now finally we can get our theta by itself. So if we multiply everything by 1/2, we would get theta is equal to pi plus 40 pi k over 40, comma, 11 pi plus 40 pi k over 40. All right, there we are. There's all solutions. So that was our part A. I'm just going to put all solutions. So since we scrolled, I'll put A as well. So these were find all solutions and then find it on the interval 0 to 2 pi. Okay, now that we've got this, we need to find the answers from 0 to 2 pi. And again, it's usually just based on a pattern. We are letting k equal 0, 1, 2, 3, however many it takes until we have all the answers. But I'm just going to highlight again and say, well, really, it is just focusing on counting by that 40 pi being added to our pi in the numerator. So when k is 0, the 40 pi times 0 would be 0, so we're left with just pi over 40, comma. And then again, when k is 0 in the second answer, we would just have 11 pi over 40. Okay, and then now we're going to add 40 pi to the numerators of these previous answers. So when we add 40 pi to this fraction's numerator, we would have 41 pi over 40. And when we add 40 pi to this fraction's numerator, we would have 51 pi over 40. Okay, so now we're just adding the 40 pi to the numerators. And then we'll keep the pattern going. Okay, so now this answer we'll add 40 pi to the numerator. And when we do, it is 81 pi over 40. And then at this point, we can say, well, that's bigger than 2 pi. So that means we do have all the answers. Okay, so I can quit this. That's bigger than 2 pi. I don't need it. We do have all of the answers. There's the 4 of them. Okay, so that's all of them. All right, so usually these special angle ones, getting to the all solutions part is the tricky part, and then afterwards it's mostly patterns is what I would think of it as. All right, so I hope that helps. If you do have any questions, please let me know. Like always, like always, if you do want to double check these answers, we can plug them back into the initial equation. We did that on this very first one. It takes a while though. So if you do want to double check, go for it. I'm going to skip that for this video because I don't think it's too necessary. Okay, so now I'm going to say thanks for watching. If you have any questions, please let me know.